Welcome back to Spring Into Math 5. This is Mr. Stein here again. Today we're going to tackle prime and composite numbers. Okay, so prime and composite numbers. So numbers can be classified into two categories. The numbers that have the number of factors that the number has determines whether the number is considered prime or composite. So prime numbers, let me start again. Sorry, man. I just like three biffs in a row. Welcome back to Spring Into Math 5. This is Mr. Stein here again, and today we're tackling prime and composite numbers. Okay, numbers can be classified into two different categories. The numbers of factors that a number has determines whether it's prime or composite. So let's look at those two definitions and figure out the difference between them. So prime numbers are special numbers that they're greater than 1, but they only have two factors, 1 and the number itself. So that means an example of that would be like 3. Only a 1 and a 3 go into the number 3. Nothing else goes into it evenly. Then there are composite numbers. These are numbers that have more than two factors. Most numbers out there are composite numbers. Okay, so here's a prime number. We talked 3, now let's look at 13. The factors for 13 are only 1 and 13. If you were to go down the line, 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, nothing goes into it except 1 and itself, making it a prime number. All right, so I'm going to show here a chart of prime numbers. I want you to take a look at it, and even just looking at it, out of 100, you can see how few numbers are prime numbers. And as it gets larger, you're not really adding any. So you only have those about 25 numbers that are prime. So, as I said, there are 25 numbers between 1 and 100 that are prime. Be particularly careful when considering the number 1. This is often a misconception. 1 is neither prime nor composite because 1's going to go into every single number. Okay, so here's a composite number. We have the number 44. The factors for 44 are 1, because 1 and 44 go into it, 2, because 2 and 22 go into it, 4 and 11 go into it, so it obviously has more than 1 and itself as factors of the number 44. So therefore, 44 is a composite number. It's made up of more than two factors. All right, so if we're looking at a question that says, prove that 91 is a prime number, first we have to list all the factors of 91. So 91 at the very least is going to have 1 and 91, because every number has 1 and itself that go into it. So then we just have to kind of keep looking and keep dividing numbers into it to find out what goes into it evenly. And so if we were going to do it, we'd say 2 doesn't go into it, 3, 4, 5, and 6 do not go into the number 91 evenly. But when we get to the number 7, when we divide that in, it goes in 13 times. We now have another set of factors. So 91 is no longer considered a prime number because not only 1 and itself go into it, but also 7 and 13. So since 7 and 13, it's not a prime number and it's considered a composite number. All right, now, last question. If a number has more than two factors, the number is prime, true or false? Okay, so if it says it has more than two factors, well, that would be a composite number, so this would be false. Prime numbers, if you recall, are just 1 and itself. So if what I want you to take away from this lesson is that 1 and the number mean it's prime, only two factors, and if it has more than two factors, it's composite. I'll see you next time.